8.4 Conservation of angular momentum. 8.4a Define and use angular momentum. Angular momentum is defined as the product of the angular velocity of a body and its moment of inertia about the rotation axis. Angular momentum juga boleh ditakrifkan dengan menggunakan formula iaitu L equals to I omega, di mana L ialah angular momentum, I ialah moment of inertia on a body, omega ialah angular velocity of a body.
It is a vector quantity. The SI unit of the angular momentum is L equal to kg meter square per second. Untuk unit moment of inertia on a body, unit dia adalah I equal to m r kuasa 2, dan untuk dapatkan unit dia, m dalam kilogram, r kuasa 2 adalah meter square, dan omega ialah dalam unit S -1. Jadi terbentuklah angular momentum adalah dalam unit kg meter square per second.
Conservation of angular momentum. State and use principle of conservation of angular momentum. What is principle of conservation of angular momentum? Principle of conservation of angular momentum states that a total momentum of a closed system about an rotation axis is constant. L equals to I omega is a constant if the total torque equals to 0. The L represents the angular momentum, the I represents the moment of inertia on a body, while the omega represents the angular velocity of a body. The total torque is dl over dt, then it equals to 0. dl equals to 0, and dl, the formula is the final angular momentum minus the initial angular momentum. So we can make a statement that the final angular momentum equals to the initial angular momentum as dl equals to 0. We can also elaborate it as I initial multiply omega initial equals to the I final multiply the omega final. Let's discuss an example. A student on a stool rotates freely with an angular speed of 2.95 revolutions per second. The student holds a 1.25 kg mass in each outstretched arm that is 0.759 meters from the rotation axis. The moment of inertia for the system of student stool without the masses is 5.43 kg/m². When the student pulls his arm inward, the angular speed increases to 3.54 revolutions per second. Determine the new distance of each mass from the rotation axis. So, the mass is 1.25 kg. The moment of inertia of the student stool is 5.43 kg/m². The RB is 0.759 meters, while the initial omega given is 2.95 revolutions per second. So we need to change it to the unit rad per second. So the value we obtain is 18.5 radian per second. While the final omega, the question gives us is in the unit of revolutions per second also. So we need to change it to the unit of radian per second. So the value we get is 22.2 radian per second. The diagram here illustrates the situation of this question. So at first, the student stretches out his arm with one masses on each of his hand here. So RB is the distance of each mass from the rotation axis. This is before. Well, after that, he pulls his arm inward. So the R decreases. Then we label this as RA. So RA is the new distance of each mass from the rotation axis. Firstly, we need to find the initial moment of inertia. I initial equals to the ISS plus IM. The SS here represents the student and stool, while the M represents the mass held by the student. So the formula for I is mr squared. So we substitute the value here after that. So ISS plus 2mr squared, we need 2 plus 2 together here because there are two masses held by the student, one on his left hand side, one on his right hand side. So we can substitute the value here. The ISS here is 5.43, the M here is 1.25, while the RB here is 0.759. So in the end, we will get the value of 6.87 kgm squared. Next, we calculate the final moment of inertia. The I final equals to ISS plus 2m RA squared. The ISS remains the same, so it's also 5.43. Then the 2 here, the mass also remains the same, 1.25. However, the R changes. So we label this as RA squared. Then we will get the equation of IF equals to 5.43 plus 2.5 RA squared. After that, we apply the principle of conservation of angular momentum, which is the final angular momentum equals to the initial angular momentum. So we elaborate this equation, then we get this. After that, we substitute the value. The I initial equals to 6.87, while the initial angular velocity is 18.5 rad per second here. Then we plus it here, the 2.5 here, we substitute the value here also. The final omega is 22.2, so it's here. Just use max, then we calculate it. The value we get will be 0.344 meters. Next, let's discuss the tutorial question from our module, which is the question 8. So, a horizontal disc rotates about an axis which passes vertically through the center of the disc with angular velocity of 100 revolutions per minute. A small particle of mass 10 gram is dropped onto the disc 9 cm from the axis and sticks to the disc. If the angular velocity is reduced to 90 rpm, which is 90 revolutions per minute, determine the moment of inertia of the disc about the axis. So, from the question, the angular velocity is given in the unit of rpm, which means revolutions per minute. We need to change it to the unit of radian per second. So after converting, we will get the value of the initial angular velocity is 10.47, while the second angular velocity that we get is 9.42 after converting it into the radian per second unit. So again, we apply the principle of conservation of angular momentum. So this is the formula we get. The final angular momentum equals to the initial angular momentum. Then we elaborate it as like this. So ID equals to omega 1 equals to ID plus IP multiplied with omega 2. The D here represents the disk, while the P here represents the particle, the small particle. As initially, the horizontal disk rotates only. There is no small particle drop or attached to the disk. So after that, there is a small particle that sticks to the disk. So we need to add the inertia of the small particle. Then now we find the inertia for the particle first. So 0.01 is the mass of the small particle. So we change the type 10 gram into kg, which is the SI unit, and the 9 cm into meters, which is the SI unit for length. Then we will obtain the value of 8.1 times 10 to the power of negative 5 kgm squared. Consequently, we substitute the value. 10.47 is the omega 1, while the D is the unknown value here. The ID is the unknown value here. So IP, we obtain it just now, so we substitute here also. Well, the omega 2 is 9.42 rad per second. So after calculations, we will get the value of ID equals to 7.26 times 10 to the power of negative 4 kgm squared. So we can make a conclusion that the moment of inertia of the disk about the axis is 7.26 times 10 to the power of negative 4 kgm squared. So that's all from me. Thank you.